Lesson 3.1 is about how to solve equations in the form of x squared equals a number. So let's review what a perfect square is. A perfect square is a number that is the square of an integer. So if I start with 4 squared, then 4 squared is equal to 4 times 4. And 4 times 4 is 16, so we say that 16 is a perfect square. How about -5 in parentheses squared? So that means -5 times -5. A negative times a negative is a positive, so we get positive 25, which means positive 25 is a perfect square. 6 squared is equal to 6 times 6, which is 36. So we say that 36 is a perfect square. And one more, 10 squared is equal to 10 times 10. And 10 times 10 is equal to 100. So 100 is a perfect square. Now let's move on to review what a square root is. The square root of a number is another number that when multiplied by itself is equal to the radicand. So we studied both of these terms in topic 1, and this is reviewing those terms. The symbol for square root is this. And it's very important that when you see the square root symbol given in the problem, so I'm going to underline the word given. If the square root is given to you, it means it's the positive square root. So if you see the square root of 4 given to you, it equals 2, because 2 squared equals 4. And when you see the square root of 25, the answer is 5, because 5 squared is 25. So we're going to come back to that idea. When the square root is given to us in a problem, the answer is the positive square root. Let's move on to squaring a number. So when you square a number, to get rid of it, you want to take the square root. So squaring a number and taking the square root are called inverse operations. Just like adding and subtracting are inverse operations, just like multiplying and dividing are inverse operations, taking the square root is the inverse of squaring a number. So when solving equations to get rid of a square, we must take the square root. So what does it mean that x squared equals 4? So we should be thinking, what number times itself equals 4? Now, the obvious answer is what you're going to come up with in your head, and that is 2. But notice that in our notes it says that there are 2 answers. It's bold, and I put a bazillion exclamation points after it, because most people don't remember that there are 2. Let's talk about it. So we know that 2 times 2 equals 4. So that means that 2 is an answer. But what we forget about is that when we multiply a negative times a negative, we also get a positive. So -2 times -2 is also 4, and therefore there are 2 answers. So 2, x equals 2, and x equals -2 are the answers to this problem. Now, the other way we could write that if we wanted to, we could put x equals, and then this symbol, which means positive and negative 2. Or we could simply write x equals 2, comma, negative 2. So you could put any one of those three things, and the three things I'm talking about are x equals 2 and x equals negative 2. You could put x equals plus or minus 2, or you could put x equals 2, comma, negative 2. But you have to remember to put both of those answers down when given these types of problems. So in general, I have a typo here. There's 2 L's in will. In general, x squared equals p will always have 2 answers. One is positive and one is negative. Now there is an exception, and the exception is when x squared equals 0. If you're given that x squared equals 0, you can't say that x equals a positive and a negative 0, since 0 is by itself neutral. So when you have that question, x squared equals 0, there's only one answer, and the answer is x equals 0. All right, let's move on to the next page. We are now going to go through the steps for solving equations involving squares. And these steps seem like a lot of steps to do, but once you get into the habit of practicing this, you'll notice that it goes very quickly. The first step is very simple: write the equation. So let's start with the equation x squared equals 81. The second step is to do the inverse of squaring, which is to take the square root. And when I do to one side, I have to do to the other. So we're going to take the square root of both sides, and this is where we have to remember there's a positive and a negative answer. So I'm going to take the square root of x squared, and I'm going to take the square root of 81. I'm going to put some asterisks by this, because this is the step where we have to remember there's a positive and a negative square root of 81. So don't forget to put that plus or minus sign, positive and negative. Step 3 is to simplify what you've done. So the square root of x squared, since square roots and squares are inverses, they cancel each other out. So the square root cancels with the square, and I'm left with x, which is what I wanted. And on the other side, I have a positive and a negative. Square root of 81 simplifies to 9. So I have a positive and a negative 9. So I could leave the answer like that. The next step, I say to write the answers. So you could write it just like that, or you could write it separately. And to write those separately, it would be x equals 9 or negative 9. This is what digits will expect you to write right here. That's what digits will require, because it doesn't have that plus or minus sign up above. So digits will require you to put the 9 and then a comma and then a negative 9. The last step is the step that most students will skip, but it is not a good idea to skip it, and that is to check our work. So the check is simply 9 times 9, because that's 9 squared, and that equals 81, so it works. And the other one is negative 9 times negative 9. So that would be negative 9 in parentheses squared, and that equals 81, and that works as well. So it's always a good idea to check your work. The next thing in our notes says, note, when you're using your calculator, you must use your brain, because the calculator will only give you the positive answer, and you have to use your brain to know that there is another answer that is negative. Our calculators will not do that for us. So make sure to know that there is a positive and a negative unless we have a 0, like I showed you before. We have